Alright, we're going to go through this example again using the graphics calculator, which I did in the lesson this morning, but perhaps I should have just recorded it live then. Anyway, what we need is a real graphics calculator, and we're going to go into graph mode. Now, they're probably still in there from before, so I'll delete the functions. We can do it all again. Okay, so we want to find and classify all points where the derivative is equal to 0. In other words, find and classify all stationary points. So we put the function 3x to the power 4 minus 16x cubed plus 24x squared minus 9 into the calculator. Okay, that's done. And we can draw that. And I mentioned this morning about the view window. If you need to adjust it, you can do it in there. Just a point of interest, if you set the x values and then you use zoom auto, then it will automatically adjust the y values. One like this though, however, because these y values will be big, it will become not quite practical, but it'll get something on the screen, and then you can go in and back into view window and manually adjust it. Okay. All right, so we've got our drawing of it. We want to classify all points of all stationary points. Okay, so we can find this one, no problem, this minimum here with gsolve, and we just select min, and that's at the point 0 minus 9. We've got that point 0 minus 9. Now the next thing, we want to find this stationary point here. Put into work where that is. Now to do that in the graphics calculator, we're going to need to graph the derivative of the function. And this is the part that I suppose is quite new. So we want to put in here the derivative of y1. You could differentiate it algebraically and type that function in, or you can get the graphics calculator to do it. We go to Options, Calc, F1, d dx is the first derivative of, now we want to put in y1, so we select y, just type in after that 1, and then this part down here is always just going to be an x, so it's not an x from up here, but an x from here. And if we draw that, that red one is the derivative, and wherever that red one, the derivative is equal to 0, we know we've got a stationary point for our original function, which is the blue one. So you can see corresponding to that, where x is 0, it's there, and also this stationary point, it's 0 there. And notice how there's no sign change indicating a point of inflection. Here it's negative then positive, indicate a sign change giving you a local min. Okay, so we want to find the coordinates of that point. So we go to gsolve, again we want to find, well, we could use a minimum on this function, but we want to find where it's 0, so that's the root. And now it's saying which of the two functions, it's highlighting the original function. We want to change it with the disk here, the one with the arrows, the scrolling bars, to that function, and hit execute. Now it's found the first 0, but we knew about that one from finding the minimum of the function. We scroll across, selecting to the right, and it's at 2, 0. Alright, now I've put the keystrokes for putting in the derivative there. F2 in that context is for calc, F1 will be the derivative, d dx. F1 then becomes y, means a y over here, and you put in the 1 for y1, and then x equals x, that bit. Now, we've found that there's another stationary point when, from this, when x is equal to 2. If we want the coordinates of that, we've got to go back to our original function and get a y calc by putting in that x value. So let's do that. So we're back in graph. We're going to go gsolve f6, gives us more options, and f1 is a y calc. And that's the function that we want to do it on. So we select it and put in our x value, which is 2. It returns that the y value was 7. Okay, so we've got the stationary points. Now we want all the points of inflection. And one of our stationary points was also a point of inflection, that one there. But we want this one here where the function goes from being convex to concave, and that's a non-stationary point of inflection. Now you could find what the x-coordinate is for that by finding the maximum here of the first derivative, because points of inflection correspond to either maximums or minimums of the first derivative. You can see that here with that stationary point of inflection, that there's a minimum indicating that that's a point of inflection, and there's a maximum here indicating also that there's a point of inflection here. So that would be one way to find it, but for the purpose of this video we're going to show how to do the second derivative, and we know that wherever there's a point of inflection the second derivative will be 0. So if we graph the second derivative and find out the zeros of that, or the roots, we'll know where the points of inflection are. So again, we do exactly what we did up here. We go option, calc, and this time we select F2 for the second derivative, and we're going to have that of still our original function, y1. So y1, and just like before, x is equal to x. This x, not that x, this x here. Okay, we can draw that. Okay, our points of inflection are going to be where this green one, the second derivative of the blue one, which is our original function, has its roots at zeros there. You can see that that corresponds to a maximum in the first derivative corresponding to the point of inflection on the function. Also, the 0 here corresponds to that minimum corresponding to that point of inflection there. So we want to find what are the x values at these. Right, back in our calculator, we want to go to gsolve and we want to find the roots of the green one, the second derivative. So not that function, not the first derivative, which you can see it's labelled it there, but the green one, which is now flashing purple, that's y3. Execute. Okay, it tells us that the first root, or 0, for the second derivative occurs at x equals 0.6 recurring, which is 2/3. So we've got the first one. We need to scroll to the right to get the second one, and that occurs where x equals 2. Now we already knew that because we've solved for the horizontal point of inflection. But we want the coordinates now of this point of inflection on the function where x is equal to 2/3. So we go to gsolve and we want to select a y-calc. That's the function. We want the blue one, the original function, and put in x equals 2/3 or 2 divided by 3. And it gives us the y value is minus 2.48. Okay, that's the end of this little video. I hope that helps you using the graphics calculator to assist with finding stationary points and points of inflection.